Hi, my name is Sophia Zimmerman, and for my Bio 182 video project, I will be discussing the evolutionary mystery of the Opabinia, an arthropod from the Cambrian era roughly 500 million years ago. On February 8, 2022, the New York Times published an article about a research study which filled in some of the gaps surrounding the evolution of the Opabinia. The Opabinia has been labeled a weird wonder, as Stephen Jay Gould, an evolutionary biologist, referred to it as. This was for two reasons. One reason is that the appearance of what the researchers believe the Opabinia to have looked like is quite strange and appears to be something almost out of this world. As you can see, it had 5 eyes and a claw-like nose. The other reason that the Opabinia is a mystery is that there are not enough fossil records, and the majority of them were collected over a century ago. On top of these reasons, the Opabinia has never been found outside the Burgess Shale, a collection of fossils that were deposited in the Canadian Rockies. In 2017, paleontologist Stephen Paetz was at the Natural History Museum at Kansas University. At the museum, he came across an interesting fossil that was labeled as a radiodont. Paetz at the time was specializing in radiodonts, and although he was unable to identify what the fossil was, he knew it was not what it was labeled. In order to reveal the identity of the Cambrian fossil, Paetz worked with a team of researchers at Harvard University. He ran the fossil through a series of phylogenetic tests, and then they used the results to compare the fossil traits with more than 50 groups of modern and extinct arthropods so that they can make evolutionary trees. Paetz and his team were able to conclude that in fact it was not a radiodont and that the fossil was closely related to the Opabinia. This was a fascinating discovery because it was the first opabinid fossil found outside of the Burgess Shale in western Utah, and it was the second opabinid fossil ever to be discovered. After identifying that the fossil belonged to the opabinid family, they named this newly found species Eudorrhea camosa. The difference between the Opabinia and the Eudorrhea camosa was that the Opabinia was 2 times the size of the Eudorrhea, and the Eudorrhea had more spikes on its tail. The discovery of the Eudorrhea was an important discovery because it helped fill in some of the gaps previously unknown. The scientists found that the Eudorrhea was an important predecessor to the evolution of insects and crustaceans. Now that we have an understanding of the New York Times interpretation of the research, we can delve into the actual peer-reviewed paper. Just recently published in the Royal Society Journal, Stephen Paetz, as previously mentioned, and Joanna M. Wolfe co-authored the article with assistance from their team, LaRossi Abril, Daly, and Ortega Hernandez. The introduction of the research paper is very similar to the topics that have already been discussed by the New York Times article. As for materials and methods, it is split up into 4 sections, starting with fossil imaging and measurements. This section discusses the conditions for which the images were taken. The photos of the fossils were taken both when wet and dry, in polarized and unpolarized lighting. They were taken digitally with the Canon EOS 500D digital SLR camera with the Canon EFS 60mm macro lens. The next section of the materials and methods is the morphological matrix. They used 43 fossil and 11 extant taxa for the matrix. They used 86 characters previously obtained from the original matrix, 14 characters with a radiodont focus, and 25 newly developed characters for a total of 125 morphological characters. The third section is labeled Phylogenetic Analysis. The analyses were conducted using BI in Mr. Bayes version 3.2.7, with influence from the Markov model. They used 2 parameter regimes, which was maximizing information and minimizing assumptions. Each analysis consisted of 4 runs of 4 change with 25% burn-in. Convergence was determined based on a standard deviation of split frequencies less than 0.01. The final materials and methods section discusses the tree space analysis. They use multidimensional scaling to plot tree space and use the Robinson's folds distances to find the distance between trees. From the data gathered, they concluded that the unidentified fossil was of the Opabinia genus and was called the Eudorrhea camosa as previously stated by the New York Times. The research paper then goes into further detail discussing the specific characteristics of the fossil. These include the trunk, lateral flaps, eyes, mouth, and the posterior. The level of certainty of their categorization is mentioned during the discussion section of the report. Overall, the findings of the report were accurately stated in the New York Times article. The research report went into greater detail, especially when it came into how the results were obtained in the materials and methods section. However, the article portrayed the main points listed from the research paper. If any individual only read the article, they would still have a good understanding of the Opabinia genus and the Eudorora camosa, as well as what these findings mean when put into context. Thank you very much.